Okay, as I mentioned in the assignment on Canvas, we want you to be able to connect up transistor circuits to form various gates. In this case, we're going to be using the BJT transistor, which is slightly different than what we did in class where we used the CMOS. But I'd mentioned, part of the reason we use TTL technology, for example, is that it's a little more lab friendly, and I know we have the BJTs in the lab, so let's go ahead and go with that. All right, so a BJT is slightly different than a CMOS transistor. You'll get into this when you take an electronics class, but it's slightly different because I think of a BJT as a current-controlled switch rather than a voltage-controlled switch. All right, so we're going to walk through this, and I want you to understand, at least at a surface level, how this is working to form either an inverter or an AND gate or a NOR gate or whatever circuit we have you build. All right, so first of all, we have these switches. I'm going to white this out so we can determine whether it's open or closed. We'll get to choose that. The other thing I wanted to do is add in some clarifying parts to the schematic. We draw these arrows and we point those to 5 volts. And what we're saying here is that we all know that there's this loop, all right, that connects the 5 volts to the power supply and connects the grounds. All right, so we're forming these circuits. All right, that was always a confusion factor for me. What do you mean by having these arrows that are pointed to 5 volts? Well, there's really a circuit that's made, but it gets tedious to show all the loops of a circuit. Okay, so in this case, let's go with the switch condition being down. We'll start with down. All right, and the very first starting point that you want to have is to try to figure out whether the transistors are on or off. Okay, and so a quick way to check on this is that this is at ground, so it's at 0 volts, and so is this. The other side of this transistor is at 0 volts. That means, typically through a transistor, if you have current flowing into the base, this middle terminal is called the base of a BJT, there'll be a slight voltage drop across the transistor. But since there's no voltage drop, right, this is 0 volts, 0 minus 0 is 0. Since there's no voltage drop there, the current coming into here is 0. All right, so I'm going to mark up this diagram, and we're going to use a color code, and we're going to put red for off, and we're going to put red is off and blue is on. Okay, so because there's no voltage drop across this BJT between the base and the emitter, this is 0. All right, and when you have 0 going into the transistor, that makes the transistor turn off or act like an open circuit. So I'm going to draw a circle around there for an open circuit. All right. So that means there's no connection in this branch to go through the 5 ohm resistor. That's an open because of the switch. So there's no current flowing there. All right. And so as I think about this, all the current must be going in this loop. It can't go down here because that's an open circuit. So it goes in this direction. So this is the current flow in this circuit when the switch is down. And so there's current flow through this LED. And because there's current flow, the light turns on. And my output is an on. Okay? All right, so that's one condition. Let's go through the other condition. Let's clear all this. Okay, in the other condition, we are going to have the transistor in the up position, the on position. So I can draw in the circuitry again, draw in the 5 volt source, connect all the grounds. That's how I did it before. Okay, so when the switch is in the up position, okay, at this point we have a place for current to flow because we have this 5-volt source. It can go through this resistor, hit this base. There will actually be a little bit of a voltage drop across the emitter, and we have a place for current to flow. Okay, so because there's a place for current to flow, the transistor turns on. Remember, that's a current controlled switch. So that transistor is on. All right, so let's put in the rest of the current. All right, because it's on, there's a path for current to go. All right, and so we can mark that. And there's a short circuit path this way. And because essentially this transistor turning on, that's 0 volts here. There's no voltage across the wire, that's 0 volts here. We are essentially shorting out the LED. All right, so current will all flow down through the path of least resistance, so it'll go in this direction. There's a small amount of current going into the base, back through the emitter. All right, but no current will flow here. So that means because there's no current, the LED is off. All right, so let me do one more case. Let's look at this circuit. All right, and let's put this switch configuration, and let's draw the circuitry around it. This needs to circle under this wire. All right, so again, our starting point is to look at the switches and figure out whether the transistors are on or off. All right, so if in this configuration, if this switch is on, my first thought is, well, there's a path for current to flow because it's not shorted, it's not zeroed out. Okay, and because that transistor is on, this is a short circuit, so there's a path for current to flow through here. All right, let's talk about the other half. Because this switch is down, that's a 0 volts, it's a 0 volt here. We know that there's no current flowing into the base of this transistor, so this acts like an open circuit. Okay. And because that's an open circuit, and this is an open circuit, there's no current flowing here. All right, and there can't be any current flowing through here. All right, and so that leaves us this branch, okay? And because this is effectively, right, this is 0 volts, this is 0 volts, these 2 points, with respect to ground, that's 0 volts. All right, so this is 0 volts, and this is 0 volts. We've effectively shorted out the LED, so there can't be any current flowing here. All right, so that shows the current configuration. Because this is no current, this would be off. All right, so hopefully this gives you an idea of how these circuits work. You can go through all the combinations of this one. You know, I could put both these in the off position. Okay, what would happen there? If I put both these in the off position, get rid of all these. If this is off, we'll erase the other thing. Then our starting point is there's no current flowing here. So this acts like an open circuit. there's no current flowing here. So this acts like an open circuit. All right, and so there's no path for current to flow here or here. So where can current flow? Well, we have a path for current to flow. It can't go down here because of these two open circuits, so it has to go this way. To make a complete circuit. And so in this case, the LED would be on. Current's flowing through there. All right, so hopefully that helps you see how all this works.